So the peer review panel and now the MTP have come to the conclusion that the effects of radiofrequency radiation on animals in this particular study are real, that there were cancer effects in the brain and in the heart, but there was also a heart disease, a disease of the heart muscles called cardiomyopathy. There was DNA damage in the brains, and there was reduction in the birth rates of animals. Put this all together, and when we consider back to the original objective of the study was to test the assumption that non-ionizing radiation, which radiofrequency radiation is, that the assumption being held widely at that time is that it could not cause adverse health effects because it did not have enough energy to break chemical bonds. Well, we now know that that assumption is wrong because of the multiple effects that were identified in the TP study.
What do you think the FDA should be doing with this information?
Well, I think their objective was to nominate radiofrequency radiation to provide the basis to assess effects on human health, because there was concern at that time that it may not be protective. Now that the results are available, there's demonstration of the cancer effects, DNA damage, effects on birth rate, effects on heart muscle. The purpose then would be is to make use of that data and provide an analysis of what the actual risk is in association with exposure to radiofrequency radiation. And this is done by agencies all the time in terms of doing what's called a quantitative risk assessment. This would be to look at the relationship between the dose, exposure, and what is the level of exposure inside the animal, and the disease outcome, which would be the tumor response. If you work out that type of relationship, then you can assess what would be the risk under exposure scenarios, which would be different than the NTP exposures. This would be, for example, less hours of exposure per day, even lower exposure intensities. If you know the relationship between exposure or dosimetry and response, you can come up with estimates of risk. FDA has done this. This is standard practice at the U.S. Environmental Protection Agency, California Environmental Protection Agency. This is standard practice by health agencies throughout the world. It is the practice of the WHO, where they also, not the IARC. IARC does qualitative characterizations of risk, but there are WHO committees that also do quantitative risk assessments. And FDA nominated cell phone radiofrequency radiation in order to be able to assess the risk to human health. Now what they need to do is conduct that quantitative risk assessment, work out that relationship, and with that relationship in mind, then the FCC, which sets the guidelines for human exposure, could develop health protective guidelines.
Uh-huh.
If the risk was 1%, that would be devastating. If 1% of the population developed the disease from a contaminant in their drinking water, that would be terrible. So what you try to do is expose to a higher level such that you can understand the risk at lower levels and characterize. And that's what the quantitative risk assessment would do. My first message is the FDA needs to do their job. They asked for the study so that they could assess risk to human health. Now that the data is available, do that assessment and estimate what is the risk to human health. a small increase in cancer risk could have a serious health impact because of the millions and billions of people worldwide who use cell phones. But another lesson to be learned from this is that when this study began, the assumption was that non-ionizing radiation could not cause any adverse health effects other than by heating. We know that that assumption is wrong. So therefore, it makes no sense to make assumptions about other types of wireless technologies unless they are tested and shown with adequate testing to be safe. So the implementation of technologies such as 5G would be implemented under the assumption that it is safe. From the studies on the radio frequency radiation, we know that assumptions can frequently be wrong, and for the protection of public health, these assumptions need to be tested.